let's discuss loans and amortization. So just as we invest money to earn interest, banks and lending institutions lend money and collect interest for its use. Federal law now requires that the full cost of any loan and the true annual percentage rate be disclosed with the loan. Because of this, loans now are usually paid off by a series of partial payments with interest charged on the unpaid balance at the end of each payment period. This type of loan is usually repaid by making all payments, including the principal and interest, of equal size, and that's called amortization. When a bank makes a loan of this type, it is purchasing from the borrower an ordinary annuity that pays a fixed return each payment period. The lump sum the bank gives to the borrower, the principal of the loan, is the present value of that annuity. And each payment the bank receives from the borrower is payment from the annuity. And the formula is the same as what we saw in the previous episodes. But if we were trying to figure out what the payments needed to be, we could rearrange this algebraically. Or we can use the calculator. So let's go ahead and plug in. So let's say a company modernizes its production by buying a new piece of equipment for $200,000. It makes a $50,000 down payment and agrees to amortize the rest of the debt with quarterly payments over the next 10 years. If the interest on the debt is 12% compounded quarterly, because it's compounded every time he makes a payment, find the size of those payments. So first off, how much is actually going to the debt? Well, we have to take off that $50,000, right? Because he's paying that up front. So we're only really putting in $150,000 where he'll be making payments. So in the calculator, hopefully by now we've gotten the hang of this, it's 10 years compounded quarterly. The interest rate is 12%. The present value is, well, it's actually positive because we hadn't paid it yet, 1,000. And we're trying to find the payment, right? So that the future value will be 0. We're trying to pay this off. And it's quarterly, so we're going to put that as 4. And we're going to leave it as end because it doesn't say that we're having to pay at the beginning of the month. And we want to find the payment, so you put the cursor on payment and press alpha enter. And so the payments need to be $6,489.36. What's the total amount of payments? So if you paid that amount, $6,489.36, over 10 years, 4 times a year, the total amount paid is going to be $259,574.40. And if you get a car loan or anything, you will see that they will calculate the total amount of the payments, including interest. And this is how they do it. So what's the total amount of interest that was actually paid? So let's think of what all has been paid. So we paid this much, but we also made a down payment, right? So the down payment was $50,000. So how much is this company out of pocket right now at the end of this loan? They're out of pocket $309,574. And the equipment was only $200,000. So the remaining amount, the $109,000, is the total amount of interest paid. Chucky and Angelica have $30,000 for a down payment, and their budget can accommodate a monthly mortgage payment of $1,200. What is the most expensive home they can buy if they borrow money for 30 years at 7.8% compounded monthly? Okay, so let's see how we're going to do this. Finance, okay. So 30 years compounded monthly at 7.8%, and we're trying to find that present value if we make payments of $1,200 and pay the whole loan off after the 30 years, and we're paying at 12. So this time we're trying to find how much that present value can be. So we're going to put it on present value, alpha, enter, and we get a present value of 166,696.65. But they can make a down payment of $30,000. So if we add the down payment of $30,000 down, then they can afford a $196,000 home. We'll round up. You'll also see sometimes when you get a loan that they'll include what is called an amortization schedule that summarizes all the information regarding the amortization of a loan. So let's say we have a loan of $10,000 with interest at 10%, and it's being repaid in 5 just equal annual payments. So our payments would be $2,637.97. Each time this payment is made, some is used to pay the interest on the unpaid balance, and some is used to reduce the principal. For the first payment, the unpaid balance is $10,000, right? So the interest payment is 10% of $10,000, or $1,000. So when you pay your payment, $1,000 of that is going to interest, and $1,637 is going to your principal. It's going to reduce that principal. So the new principal, the new balance, is $8,362. They take that, 10% of that, and that's your interest on the next payment. So as you go through, you're paying more on your principal. So at the very beginning of a loan, you're paying more to interest. And then as the balance goes down, so does the amount you pay to interest, and the amount you're paying that goes to your principal goes up. See how this works? So after you make the next payment, only $836 is going to interest, and $1,801 goes to your balance, leaving a new balance of $6,560. 10% of that would be the interest for the next payment, leaving us here interest of that, and so forth until it's all paid off. Note that the last payment increased by 3 cents, so the balance reduced to zero. That happens a lot because when we figure out the payment, we're rounding, and sometimes it doesn't come out even. Okay. Calculations for amortization of a debt are based on the present value formula. Because of this, the unpaid balance of a loan, or the payoff amount, the outstanding principal, is the present value needed to generate all the remaining payments. So we can also figure out unpaid balances. And we have a formula here for those of you who like to do it by hand. But let's say a young man decides to stop using a credit card after he acquires an outstanding balance of $15,000 with an interest rate of 18% compounded monthly. He makes monthly payments of $270.28, which will pay the debt in 10 years. After 6 years, he gets a new, better paying job and decides to pay off the unpaid balance. Find the unpaid balance after he makes those payments over 6 years. So the balance after the 72nd payment would be our value with how many payments remaining. So the remaining payments, we're going to find the present value with remaining payments of, so if it's 10 years, 12 times a year, that's 120, minus the 72 we've already made, leaves me with 48 payments remaining. So in a calculator, I'm going to go into the TBM solver, and I'm going to put 48 here. Interest rate was 18%. We're going to look for the present value after he's paid $270.28 compounded monthly. The remaining balance, or the unpaid balance, is going to be $9,201.02. Okay. Oh, that should have said present value, not RV. Anyway, loan refinancing. 4 years ago, Benacourt decided to expand its production capacity and borrowed $1.3 million for 20 years at 5.2% compounded quarterly. After making 16 quarterly payments of $26,000, 235. Well, anyway, Benacourt was considering refinancing this loan for 15 years at 4.8%, with refinancing charges of $5,000 added to the amount of the new refinanced loan. So the first thing we want to do is find the payoff amount of the Benacourt's original loan. So it's going to be the unpaid balance after how many payments? So after 16 payments. So that leaves remaining would be, so 15 years quarterly. So that's 15 times 4. Whoops. Wait, 20 years. I'm sorry, 20 years. Oh, why did I say 15? Oh, that's the new loan. He was doing it for 20 years quarterly. So 80 minus the 16. That leaves us with how many? 64 payments remaining. So I'm going to go in here. And we have 64 remaining. The interest rate that he was at was 5.2%. We're looking for that. He was paying $26,235.37 quarterly. So that's a 4. So the payoff amount, the present value or the payoff is $1,135,148.82. Let's go all the way. Find the amount of the new loan and the new quarterly payment. So we've got this the unpaid balance plus the financing charge. So plus $5,000 for financing means that we are going to be financing how much? Well, that would be make it $40,148.82, and we want to know what the payment would be. So let's go in here, and so for the rest of the time, that's 15 years quarterly at a new interest rate of 4.8, and we're putting in 1140148.82, and we're trying to find the payment. Oh, and it's set on quarterly. Okay, so out the enter. $26,766 and basically 30 cents are the new payments. New payments. So should he refinance? Well, if he kept with the original loan, he was making payments of $26,235.37, and he had 64 months left on that loan. So how much would he pay overall? Total payment would be 26,235.37 times 64. Pay 1679063.68. So $1,679,063. With the new loan at $26,766.30, but for how many months? For 60 months, the total payment would be $1,605,978. So overall, is paying it off a year quicker, less payments, and the total payments made is actually less. So it is a better deal.